So this is an old mill house, a couple of 100 years old. The mill race, you can still see it down there. So this is the main house. The Cork House is here, it's a separate house. There are lots of things called cork houses and things, but they're normally cork clad. It's not normally used structurally. These walls are just made of nothing but cork blocks, and they're assembled just by putting one block on top of another. There's no glue or mortar, there are no tie rods or anything. It's as simple as it looks. This is the first building to be built using this system that we developed in a research project. We wanted to make a simple form of wall and roof construction, and we identified cork as potentially being ideal because it's got an unusual combination of properties. Yeah? So it's used as a thermal insulation material. It's been used as internal linings for, well, hundreds of years. So including a lot of modernist architecture like Falling Water by Frank Lloyd Wright has bathrooms lined with cork. It's been used as an external cladding, expanded cork, for about the last 20 years. And there's some record of it being used in self-supporting walls in cold stores in the 20th century. So we knew it had some load-bearing capacity. So the idea behind the project was really, let's try and use cork to fulfill all of those different performance roles that in modern buildings are normally done by steel, plastic insulation, plaster, timber cladding.
Is there any reason for this type of roof, which is so unique?
Well, we wanted to keep the assembly and disassembly simple, so we didn't want to use a different roof system to wall system. And with corbelling, where you just offset the roof a small part each time, it doesn't need that elaborate false work underneath. Yeah? Whereas if we'd used, for example, a dome structure or something, you need a huge amount of support structure while you're building. Yeah? So this particular geometry gives you a kind of defined space for each of the various uses in the house. Yeah? So the house is formed of these 5 pyramid structures. This first structure is an entrance structure. You hang up your coat, there's a bathroom, and that leaves the pyramid above as a sleeping platform. And then you walk through into the kitchen dining area. But we can open that up, and obviously on a nice day you can just, indoor or outdoor, you just spill out into the garden. And then on colder winter days it stays fairly cosy here because this is an insulation material, 1/2 metre thick walls, and there's a wood burning stove here. So what you can see here is, this is the bare cork again, the inside face of the blocks, and you can see it's darker here because it hasn't silvered because it hasn't been exposed to sunlight, although it's starting to lighten a bit. So in terms of the purity of just using cork as an external wall and roof system, on the roof we added a bit of timber weatherboarding, and internally we've added a foam air tightness tape which just sits 10mm deep because we wanted to increase the air tightness. So it's a foam tape that you can easily remove. At the end of life you'd just take the blocks off and it would just come out. If you look at what we've got here structurally, these are a bit like Syrian beehive houses which date back a long time. But they are a modular structure, so you literally get a closed structure next to a closed structure with a door in between. But we wanted to open this up and to give wider views to the garden. So what these beams do is they support the weight of the roof structure as it comes down and transfer it onto the wall. Yeah? So the cork's working in compression, takes all of the downwards load, and where we've got openings for doors or where we want to take a wall out, then these transfer the load. And the only other thing that the timber's doing structurally is there's a ring beam around it. I mean, you can see it above the windows. This here, that's a ring beam that goes all around at the eaves and helps to take the lateral loadings.
There is something very unique here. Are these blocks completely new? I mean...
Not at all, no. Okay. They were invented in the late 1900s by accident by a life vests manufacturer. They used to fill them with cork granules. He accidentally left a cone full of these granules by the fire, and overnight they congealed into this dark brown mass, and he understood that there was some potential there and patented these expanded cork boards. Then it all went from there. So this expanded cork was a sort of industrialised product that was used very widely to insulate cold stores, and then it started to be used to insulate houses, to keep them warm rather than cool, and so it's got quite an extensive history of use in several continents. But we're not aware of it having been used structurally before like this on any permanent structures. The material itself, in the first half of the 20th century, was one of the major thermal insulation materials used globally. Yeah? And then as plastic foam insulation came on stream after the Second World War, then this started to be used a bit less. So it's not a new material. And cork itself has been used in building for thousands of years. It's documented in Roman times as being used for roof sheets. This is actually a cork oak. So cork is the outer bark of the cork oak tree, Quercus suber, and it's found all around the Mediterranean basin, and it's been used by people for thousands of years in construction, for winter footwear. When it's farmed, about every 10 years, this outer bark is stripped off, which is a bit like giving a person a haircut. It's a dead material, it doesn't harm the tree, and that's heated and formed flat to give you big sheets of cork, which people just used to put on roofs and things like that in Roman times. But now most of the high quality cork's used in wine bottle stoppers, but it leaves about 3/4 of the cork. So the cork that we used on this project is granulated, left over some wine stoppers and from Cork Oak Forestry. You put it into a big autoclave, big pressure cooker, and the natural suberin in the cork, which is a natural resin, melts and then rebonds again to give you expanded cork, which is what we got here. So it's 100% plant-based material. It doesn't have any plastic binders or anything. These are some of the blocks that we used to make the house, and you can see the way they fit together. There's no glue or mortar. There's simply a tongue and groove geometry. There's the groove, and there's the tongue, and then this is the tongue for lateral blocks, and same there. So you can see that these just, when you build it, you just put one on top of the other and just sort of slide it in. There we go, and it just goes down like that.
That's structural.
That's structural, yeah. There aren't any cables or anything in the house holding it down. The roofs are a corbelled geometry, and you can build it as simply as you build a wall. You just put one block on top of another. There's a small cantilever each time. You don't need any formwork inside to support it. So that was important for us because we wanted simple assembly by hand. And we also wanted the building to be simple to disassemble at the end of the building's life. Yeah? So you could reuse the components.
So you don't need machinery?
No. So the owners are Matthew and Dido, the other two architects involved in the project. And Matthew built this himself with one assistant. The fabrication was quite challenging to get to the point where we could robotically mill the cork blocks. And then working with what Doodle, the CNC fabricator, to shape the blocks. But the actual assembly process was as easy as we'd hoped it would be. They go in just like jumbo toy blocks, really. That's how it goes together. You literally just pick a block up and no glue, no mortar or glue or anything, and it's called an interference fit. That just means it fits quite well. Certainly, this building from the slab up is simpler to assemble than some Lego construction kits that my son was building when he was about 10, which have about 400 steps. It's fairly simple. There are quite a lot of block types, running into dozens, but so long as they're clearly numbered and you've got the plans, so you need the plan for each course, so you know what block types to put in, then it's pretty straightforward, really. You know, after half an hour you've got the hang of it, and they go in just like, yeah, jumbo toy blocks, really. It's as simple as that. And then obviously you need a bit more muscle and a bit more care when you're lifting in some of the larger timber elements that go in at eave level. So that was the aim, and it worked, so there we go. The funny thing about this house, or one of the funny things, is that we used emerging technology to fabricate the blocks, and without access to CNC machining it would have been difficult to shape the blocks, to make them watertight, airtight, all these sorts of things. But the way that the building was assembled would be probably familiar to some builders 4,000 or 5,000 years ago, because it's a very rudimentary process of just putting one block on top of another, which back in those days would have been stone, a dry stone system, and we substituted that for cork. So yeah, it is like some of the temples in Bali that I visited, other temples in Indonesia. You can find these sorts of corbelled structures all over the world. They're also used in things like goat herders' huts in France 1,000 years ago. This form was very widely used pretty much across the whole world, really. That's just a Lego corbel, and it's kind of the same assembly method, really. You just take a block, put it on. It's a interference fit, the same as we've got here. Push it on, and then you've got a corbel. And it sort of also illustrates, you know, you can build that without need for a structural framework underneath, because it's pretty much self-supporting as it goes up. So these bolts here transfer, when it's a windy day, those sideways wind forces travel along here, and they're transferred via a metal bracket down into these structural CLT wardrobes. Yeah? So they're not taking any of the weight down. There's a slotted fitting here so that this naturally settles and transfers the loads to the walls. But on a windy day, these take the lateral load out of the beams down. Yeah? And again, so in the end walls, it's just the walls that do that. But we wanted the interior to be reasonably open plan. So that's why we introduced these structural wardrobes that take the wind load down to the floor. So this is the end pyramid, and this is the most private one, which is the bedroom. And it's possibly the most amazing room, actually, as a place to sleep. When at night you look up, you can feel yourself under this sheltering structural cork pyramid, and you can look out through the roof line and see the stars if it's a clear night. You should have a go. It's really good. It's, you know, until you actually do this, you don't really get it. It's great. But you can feel the weight of the structure sort of sheltering you. And that view out to the sky. It's very relaxing. You don't feel like you're having a fight with the architecture somehow. You can just fully relax and kind of soak it all up, which is it's a really nice aspect. Yeah. Oh, it's really nice.
Oh, you don't have to.
Yeah, you just don't want to, you know, you should give it a try, you know, if you get a minute. In terms of materials, you can see we've tried to use plant-based materials wherever possible in the interior. And wet surfaces internally generally use brass, which handles water well. It can be easily, again, it's unlacquered, so it can easily go back into the manufacturing chain at the end of life. In terms of building services, the electrics run in a slot in the floor. So that's where the plug sockets are for lights and things like that. Routed out in the CLT, and you can just take this board out to get to them. There are risers in the CLT structural wardrobes, and then when you get up to the cork pyramid level, there's nowhere to hide for services. Yeah? They're all exposed. This is a sprinkler system. That's a pipe for a sprinkler system. The fire strategy includes sprinklers because we didn't want to treat the cork with any fire retardant, which would mean it wasn't pure at the end of life. You couldn't just crumble it and return it to the soil if you wanted to. It would pollute. And also we didn't want to decrease the quality of internal environment by adding chemicals that possibly could have sort of slowly poisoned the inhabitants. Yeah? So the way to deal with that was to add the sprinklers. And this other pipe here is an electrical cable that runs up to the roof light, which is powered opening. So when it gets warm, you just pop it open. Yeah? This is the furnishing here is inlaid brass, takes water. This is recycled CLT made from spruce. These units are spruce tri-ply. See bits and pieces inside.
All very natural. This is all brass, right?
A lot of brass going on.
Beautiful.
So things like there's a inbuilt extract. Makes it quite cosy in the evening and just kind of non-aggressive somehow. It's a very relaxing place. There we go.
I think that's
bit of water. Yeah. So this is a bit more fruity and playful than the rest of the house architecturally. So again, you can see solid brass bath suite. It's just unlacquered brass, which is a material that will last for ages and can just be recycled at the end of life. So rather than your typical bathroom suite would be possibly a mixture of ceramics and maybe a plastic bath and that sort of stuff. And you can see, I don't know, you can see on the ceiling, there's a frieze, which is sort of playful frieze that sort of relates to the roof pyramids a bit. You really have to lie in the bath to fully appreciate it. Then you know, it was sort of designed to be viewed from the bath perspective. Within the cork pyramid, there's a solid CLT box assembled, which is where the boiler sits, the bathroom, sink for the kitchen, like a big piece of fitted furniture, and it's a sleeping platform. So if you want to, you lift this ladder out and just pop it up. So you just climb up. Oh. So you can see when you come up here immediately, oh careful, bit of a squeeze. So you can see that it's immediately quite a lot warmer. You can really get the toasty cork smell up here too. So it's quite nice. Wow. It's a good hideout, isn't it?
So this is a sort of second floor, but it's not structural with the cork.
Yeah, no, it isn't, but I mean, it could have been. There's no issue around whether the cork could take this additional load or not. So my two kids slept up here last night. For them, it was a bit like a really nice tent. Yeah, because they're both quite into camping and the geometry is a little bit tent-like, but just much more comfortable. We're not surrounded, we're not like in plastic. When we were developing the system, we were looking at historic forms of brick construction, Regency townhouses and things. So in terms of structure and construction, there's quite a lot of similarities, but in terms of experientially, this is obviously a softer, warmer material. Yeah? I mean, the way you feel thermally is partly the air temperature and partly the radiative temperature of the surfaces surrounding you. So if you're getting a big difference in those two, you tend to always feel uncomfortable. But here, they're well balanced, so it's not just about a look, it's about the aroma, about the acoustics.
The gutter is beautiful. It became a fountain.
Yeah, you can see the drainage in action. And there is I understand there's a frog that lives in that pond, but I haven't seen it. That drains down into a small pool, but then just drains straight down into the Thames. Get amazing aromas, don't you?
Yeah.
I mean, the Thames is just over there, and these are just sort of little, I don't know what they're called. It's not tributaries, is it? Just a branch. Maybe it's just called a branch or something. Matthew had the idea to use cork constructionally initially. What really changed things was when we got research funding to enable us to really develop a system that could do this. Yeah, so these buildings were part of the research. Well, this one, Matthew and I made about 6 years ago. Expanded cork blocks, but it's got timber profiles in, and it's bonded together with lime mortar that sits in here. So in some ways it's quite a conventional masonry type structure. We wanted something that was fairly simple to make. A benefit of putting in these dowels, you've got a cork block of certain geometry, and all you need to do is just put some slots in it and you can join it together. Whereas the tongue and groove system that we're using requires milling away of more of the volume of the cork in order to do that. But the reason why we kept with pure cork was because this forms the timber within the cork has the potential to rot, because cork is less rottable, if you like, than timber, and it's got quite different characteristics. And another thing is that these profiles have the potential to create a pool for water. So if any water did, for any reason, get through an open joint or something, it's quite likely to just remain there. Yeah? And when we'd finished this, we thought that this approach had some potential, but also that this was quite a defective sketch design that we'd done here, and we'd already added quite a lot of complexity back into the system. So this was a small prototype, cork cabin. You build the wall course by course. In this case, this is an oak ring beam, which takes the lateral loading. You slot in a copper gutter, and then you start building the cork corbelled roof. This timber weatherboarding gets screwed in, which just sheds some of the rainwater off of the roof, which is what it needs to make it properly watertight. When you get to the top, you can see there's a timber ring beam there that supports a roof light, which lets light in and also helps to weigh down the top of the pyramid so that there's no chance of it getting blown away on a windy day. This was a test building which was designed, we tried it, some things worked, some things failed. There are a lot of small design adjustments in the system that we used in the house. This ring beam, there is a ring beam like this in the Cork House, but it's turned around and it's better integrated. So this was just a more primitive, less well thought out arrangement. It wasn't like a design project. We wanted to see if stuff worked or not. So it wasn't a matter of hesitating. It was almost the opposite. It was like saying, let's see if that really will work or not. And actually this thing over here, that's the panel that we lab tested for water tightness. Placed at the end of a wind tunnel, wind-driven rains fired onto here. And this was the second test panel that we developed after the initial one wasn't successful. And this one worked very well. There was no water ingress whatsoever. Well, the aim was that we wanted this material to do everything. And what we found was that, broadly speaking, on the wall it could. On the roof, what we found when we lab tested it, was that if you have water just sitting on horizontal or inclined faces, this is it's a little bit porous, a bit like brick, where it will absorb, and it really wasn't suited to unprotected use on the roof. So we added timber weatherboarding on the roof just to shed that water off the inclined faces. Then that worked fine too. So yeah, let's have a look. Yeah, so I mean that's cork bark.
So this is what comes off the tree.
That's what comes off the tree. That's probably the first strip. When it's stripped initially, it's quite uneven, and I think it's not until the third strip that you get a more even sheet that can be used for wine corks and things. Yeah. Any leftover cork like this gets granulated, so they're the granules. This sort of stuff makes a lot of things, including agglomerates with polyurethane. That's polyurethane in cork, so it's much more robust. It's got quite a high plastic content. Quite a lot of these are more plastic by weight than cork. Yeah. And the cork that we used in this project is called expanded cork, which is mainly used for insulation, which are these are some different grades of it. This is just two chopped off ends of roof block. So you can see how it tongue and groove vertically, and also blocks, when blocks are butt on the roof, they just slot together like that. But obviously they're normally 1 metre wide each. And they were all cut with an industrial robot with that single cutter. This spins, it's a high volume cutter, it strips a load of cork off here. And it's also the cutter used for all of those little slots and things which we introduced to deal with water and air tightness issues. Yeah, so if you open this up, you can see their geometry there is such because that's what the cutter does. So we developed the block shape to enable us to cut it with robot milling. I work at the Bartlett UCL, and we've got a robotics lab there and lots of clever colleagues who know how to do this. So we worked with them to develop a robotic milling method that works. Yeah. These robots are used in the car industry, and they're not that widely used in construction at the moment, so it took a bit of effort to tame the robot to get it to do exactly what we wanted it to do. We couldn't have developed the project in the way that we did 30 years ago with the resources that we had. It would have taken a lot more resources. Yeah? And then at the end we might have ended up with a system that was all very clever, but it took one person 3 hours to shape one block or something. Whereas in the end with the milling process we got this down to under 10 minutes a block for milling, so you just stick it on and it just shapes it. That's just a photograph of Cork Oak Forests. So these forests have existed for millennia, and they do help to sustain the hydrology in the area to stop them desertifying. And they also, this mixed forestry and farming tradition supports quite a rich ecosystem. Wine stoppers, this is the waste, that's sort of granulated and then mixed with polyurethane to make things like this. Yeah. So the type we're using is expanded cork. That's used in the Matadero in Madrid over 100 years ago. This is an example of just using it as a load-bearing structure in a cold store in the States in the early 1900s. So we knew it had some kind of self-supporting qualities. So that's the Expo 2000 Portuguese Pavilion for Hanover by Caesar and Suter de Moura. That was the first external cladding use of this expanded cork. And that's still doing well now, relocated to Portugal. That's more about how complicated walls have got these days, really, and how that can often lead to this sort of thing, which is destructive demolition. Well, it's too expensive to take them apart again, you know. Nobody's going to pay loads of money to have some highly paid tradesman come and carefully disassemble buildings. So the principle with the building is that it should be plant-based where possible, and it should be easier to disassemble for reuse of everything at the end of the life. And when we added other elements such as timber weatherboarding, that's screwed in, it's another plant-based material, so you can just easily take it off at the end of life to reuse it.
So it is successful in the sense that it's easily disassemblable, it should be.
Yeah, absolutely, yeah. Well, in the research we built all the cork capital and we assembled it at the Bartlett just to make sure it all fitted together. Then we disassembled the blocks and took them to site for reassembly. And the disassembly was as simple as we'd hoped for. Some earlier geometries, which had a tighter fit, ripped when you tried to disassemble them. Yeah? Okay. So what we've got here is an interference fit that's snug but not overly tight, so that you can literally just lift the blocks off again afterwards. Yeah.
So as far as where the material is coming from, you think there could be a potential issue there by the amount of...
There's quite a lot of this material. I mean, there's a lot of this byproduct from cork industry and also from cork forestry. So they have to maintain the trees, and when they take small branches, the cork on those isn't of the quality that they could use for wine stoppers. So this is where a lot of the lowest grade cork's used. And they're quite big industries, so there's a lot of this stuff available. You know, I mean, this was really widely used material before foam plastic insulation came in after the Second World War. And I think there's still a lot of capacity to make it in quite large quantities. To an extent, it's like any other plant-based material. If there was more demand too, they'd simply just plant more.
So how long could this last?
Well, we've designed it with the aim that it could last indefinitely, in the same way that good timber buildings can last hundreds and hundreds of years. We did 3 years research developing the system so that it drains well and it doesn't trap water, and so that's certainly the hope, that it will last as well as a well-detailed timber building.
So, but you didn't treat the walls, and you didn't need to do that, or treat the exterior.
No, I mean, it's not readily biodegradable, this sort of cork, because of the chemical composition. If you grind it up and put it into the ground and the right sort of bacteria get to it, it will eventually break down, but it's not readily biodegradable. So we think that so long as it's well drained, it should just go on and on, really.